It's Kevin with Matt Practical. This is lecture 4 for Advanced Cartographic Design, Color Theory for Cartography. So today we're going to talk about color on our maps and what that means for the audience's response to our maps. Color is one of those things that's really easy to get wrong, and you know it, right? By the response of the audience. But when you get it right, it can actually give your map personality. But what is this thing, color? Where does it come from? It's a property of light, right? It's intrinsic in the photon wavelengths of light. We, as humans, can only see color because our eyes have evolved to differentiate the subtle changes in the wavelengths of light over millennia. Some people see color better than others. However, every eye or every pair of eyes has a unique range of color that they can see. Some, like colorblind people, can barely see any color, if any at all, and others can see millions of colors. And every human also has a different emotional relationship with color, and that depends on a lot of things, including the environment you're in right now and the environment you were brought up in, the culture you were brought up in, and we're going to go over some of that today. So colors on our maps can be thought of as personality. They make our maps have a voice besides just the line work, the polygons, the raster work in the back, maybe the type work. The color also expresses a feeling with our maps. But first, how can a photon have a wavelength? Let's take a quick look at this video.
One of the most striking properties about light is that it has color. To understand the phenomenon of color, it helps to think about light as a wave. But before we get to that, let's talk a little bit about waves in general. Imagine you're sitting on a boat on the ocean, watching a cork bob up and down in the water. The first thing you notice about the motion is that it repeats itself. The cork traces the same path over and over again, up and down, up and down. This repetitive or periodic motion is characteristic of waves. Then you notice something else. Using a stopwatch, you measure the time it takes for the piece of cork to go from its highest position down to its lowest and then back up again. Suppose this takes 2 seconds. To use the physics jargon, you've measured the period of the waves that the cork is bobbing on. That is, how long it takes a wave to go through its full range of motion once. The same information can be expressed in a different way by calculating the wave's frequency. Frequency, as the name suggests, tells you how frequent the waves are. That is, how many of them go by in 1 second. If you know how many seconds one full wave takes, then it's easy to work out how many waves go by in 1 second. In this case, since each wave takes 2 seconds, the frequency is 0.5 waves per second. So, enough about bobbing corks. What about light and color? If light is a wave, then it must have a frequency, right? Well, yes it does, and it turns out that we already have a name for the frequency of the light that our eyes detect. It's called color. That's right, color is nothing more than a measure of how quickly the light waves are waving. If our eyes were quick enough, we might be able to observe this periodic motion directly, like we can with the cork in the ocean. But the frequency of the light we see is so high, it waves up and down over 400 million times a second, that we can't possibly see it as a wave. But we can tell, by looking at its color, what its frequency is. The lowest frequency light that we can see is red, and the highest frequency is purple. In between, all the other frequencies form a continuous band of color called the visible spectrum. So, what if you had a yellow pencil sitting on your desk? Well, the sun emits all colors of light, so light of all colors is hitting your pencil. The pencil looks yellow because it reflects yellow light more than it reflects the other colors. What happens to the blue, purple, and red light? They get absorbed, and the energy they're carrying gets turned into heat. It's similar with objects of other colors. Blue things reflect blue light, red things reflect red light, and so on. White objects reflect all colors of light, while black things do exactly the opposite, and absorb at all frequencies. This, by the way, is why it's uncomfortable to wear your favorite Metallica t-shirt on a sunny day.
Okay. We'll leave it to me to get a Metallica reference in there, huh? Okay. So wavelength is the color, right? That is what we see as color, is the actual wavelength of the particle of light. It's a photon and it's a wave. I know it's crazy, but this isn't a physics class. And it absorbs that extra light spectrum as heat. So whatever property of color the thing has, it reflects that property of color, and the rest of the spectrum is absorbed and then heated up. If you have a map out in the sunlight, or geez, even under fluorescent light, the colors that you put into your map are going to be reflected into the user's eyes, but the ones that the pigments on the page are not reflecting are absorbed. So your map actually heats up when you use it. It's kind of an interesting fact. So the question is, if you're stuck in the woods and you have a map, can you stay warm with it? And I would say, if it's in the sun, maybe. Color perception is partly psychological, though. So there's the physical properties of light and how our eyes work, and we'll look at that in a little bit more detail here in a second. But color really depends on the individual. Each person is going to have a different relationship with color. Depends on your personality. It depends on your mood. You can have a different reaction to a color depending on how your day is going. Depends on your age, right? And your gender. And it also depends on the culture that you were raised in. So if you go to India after you've been raised in the United States, you're going to see colors that don't meet the normal expectations of meaning that you would have from the West, right? But it also depends on your experience and environment, right? So it depends on how you were raised. It depends on the experiences you've had in your life. If you had a traumatic experience that associates with one color, it might not mean the same thing to you that it does to the rest of your culture or another culture, right? And then also the development of your eye and how it can read colors depends on the environment you were raised in, if your eyes got enough nutrition as you were growing up, right? So if we could get this to work, there we go. How does this color make you feel? Got this nice big red circle. It probably gives you an emotion, right? In the West, it might mean something like danger. But in France, it equals aristocracy, right? In China, it's the color of happiness. In the United States, yeah, danger. We have it on our stop signs, right? Red lights. In India, it means life and creativity. And in Egypt, it means death, right? So what's the color of a funeral in America, if you think about it? Well, it's not red. And in Japan, it means anger, right? Which is interesting that it ends up being, such a key component of their flag. So watch that big red disc for a second. Just stare at it for a while. How many people saw purple on screen? There was never any purple on screen. We had tuned our color sensors in our eyes to that red circle, and as it slowly went to blue, we got the intermediate color of purple. This happens with our maps too, by the way. If you go from one light source to another, the colors reflect in different ways, and it can totally change the mood of the map. So I recommend you take your maps after you've printed them and look at them in the office underneath the fluorescent lights, and then take them outside and see what they look like under the bright sunshine or on an overcast day, right? So blue, how does blue make you feel? Well, blue generally makes me feel calm. That's why they paint it, not just because of me, but because it makes most people feel calm. They paint the drunk tank in blue. They don't paint it in red, right? They want everybody in there to calm down. In France, it means freedom, though, right? In China, it's the heavens. In the United States, it's masculinity, right? This is what we do with all the little baby boys. They get blue everything. In India, it's Krishna, one of the gods, right? In Egypt, it means virtue or faith. And in Japan, it means villainy, right? So let's take a look at this next color. Watch. Did anybody see aquamarine? There was none. It was just a difference between blue and green. This is mixing colors, and we're going to go into that in this lecture. You're actually going to do some color mixing with watercolors because I think it helps understand how we get from primaries to secondaries and even tertiary colors. So green, what does it mean? Well, in France, it's criminality, right? In China, an entire dynasty was able to grab the color. The Ming Dynasty grabbed green. United States, safety, right? It's green, it's okay. It's okay to go at the stoplight when it turns green. India, prosperity. In Egypt, fertility. And in Japan, it's the color of the future. And we'll switch to another one. Maybe the little clicker would work. Here we go. And somewhere in between, right? Yellow. What does yellow stand for in your eyes? Well, in France, it means temporary, right? In China, it's power. In the United States, it's cowardice or caution. In India, it means success. In Egypt, happiness. And in Japan, nobility. It's the color of nobility. So each one of these cultural influences gets ingrained in people who grow up in that culture. It doesn't mean that the color can't mean other things and it can't be associated with other patterns in life, but the culture has a huge influence on what the main designation of a color is. Let's see if we can get this to go. And then finally, a fade to white. So what does white represent? Neutrality, right, in France. China, it means death. Very different than what it means in the West, right? What means death in the West? Black, of course, right? United States, purity, right? So we send the brides down the aisle in a white dress, right? But in India or China, that would actually be the color they would wear at a funeral. India, death again. Egypt, it's joy. And in Japan, it means death as well. So the West has it exactly backwards to the East as far as the difference between black and white. Interesting. There's also huge differences between gender. So ask yourself right now, what is your favorite color as a male or a female, right? Or anything in between, any gender that you identify with. You probably still have a favorite color. It turns out that when they measure men, the favorite color is blue. The least favorite is brown, which is interesting because we wear brown all the time. I got brown on my hat. I have tons of brown pants, right? So what do you think it is for females, though? Would many of you suggest that it's pink? Well, it turns out it's almost exactly the same as males. Women love blue, especially nice, rich Carillion blues, right? So why do we drive all young female toddlers into pinks? Well, I don't know. It's just a cultural thing that we've decided to do, but pretty much only in the West. It's not that way everywhere else. But this is good for us as cartographers because we can tell that if we want to have a color that people can relate to and they're going to like, blues will definitely fit the bill. Also greens, right? And then some reds, purples, it starts to deviate. But over there on the right-hand side, browns are what each sex tends to dislike the most. All right. Also age preferences. If you're a kid, you like the primary colors, the super saturated colors, stuff that looks like it's candy, like it's going to have a really nice flavor to it, right? But older people like subdued colors. And as a cartographer, I had to learn this the hard way. I don't know why, but my 7-year-old brain really never grew out of liking super saturated colors. So I would make maps that would look like, they belonged at the circus. And, I thought they looked cool, but when I showed them to other people, they thought, those are a little bit, wanky colors. We want to tone it down a bit. Turns out adults like to tone it down a bit. And since most of the people that pay for my maps are adults, then that's what I have to do to, make them happy. Young boys under 10 like and use a lot of color, right? They tend to draw really hard with the crayons, right? And older boys and men don't like a lot of color. We all have, blue, brown, very subdued wardrobe, right? Women tend to have a better sense of aesthetic color than men. In fact, women make much better graphic designers, interior designers, pretty much better everything. But when it comes to color, they just blow us out of the water. So in the current environment right now, women are really skyrocketing to the top as cartographers and graphic designers. And I think it has a lot to do with their sense of style, right? So this might be a kid's palette, right? You see this all the time in tourist maps, really bright colors, lots of cartoony looks to them. And so much so that the software that we use for cartography and graphic design has swatches that are designed just for kids. So that's the kid stuff swatch palette. And there's multiple different color swatches that are related just to the colors that kids like, right? You won't get a chance to use them on maps too often, but occasionally you're making a map that's designed specifically for children. And that's your go-to color swatches. Now we're going to look at a lot of different swatches and the more subdued colors that tend to be better for our cartography. All right. But first, let's just think about how do we actually see color, right? What makes our eyes turn white light into colors?
light is a kind of wave, and that the color of an object is related to the frequency of light waves it reflects. High-frequency light waves look violet, low-frequency light waves look red, and in-between frequencies like yellow, green, orange, and so on. You might call this idea physical color, because it says that color is a physical property of light itself. It's not dependent on human perception. And while this isn't wrong, it isn't quite the whole story either. For instance, you might have seen this picture before. As you can see, the region where the red and green lights overlap is yellow. When you think about it, this is pretty weird. Because light is a wave, two different frequencies shouldn't interact with each other at all. They should just coexist, like singers singing in harmony. So in this yellow-looking region, two different kinds of light waves are present. One with a red frequency and one with a green frequency. There's no yellow light present at all. So how come this region, where the red and green lights mix, looks yellow to us? To understand this, you have to understand a little bit about biology, in particular about how humans see color. Light perception happens in a paper-thin layer of cells called the retina that covers the back of your eyeball. In the retina, there are two different types of light-detecting cells, rods and cones. The rods are used for seeing in low light conditions, and there's only one kind of those. The cones, however, are a different story. There are three kinds of cone cells that roughly correspond to the colors red, green, and blue. When you see a color, each cone sends its own distinct signal to your brain. For example, suppose that yellow light, that is real yellow light with a yellow frequency, is shining on your eye. You don't have a cone specifically for detecting yellow, but yellow is kind of close to green and also kind of close to red, so both the red and green cones get activated and each sends a signal to your brain saying so. Of course, there's another way to activate the red cones and the green cones simultaneously, if both red light and green light are present at the same time. The point is, your brain receives the same signal regardless of whether you see light that has the yellow frequency or light that is a mixture of the green and red frequencies. That's why, for light, red plus green equals yellow. And how come you can't detect colors when it's dark? Well, the rod cells in your retina take over in low light conditions. You only have one kind of rod cell, and so there's only one type of signal that can get sent to your brain, light or no light. Having only one kind of light detector doesn't leave any room for seeing color. There are infinitely many different physical colors, but because we only have three kinds of cones, the brain can be tricked into thinking it's seeing any color by carefully adding together the right combination of just three colors, red, green, and blue. This property of human vision is really useful in the real world. For example, TV manufacturing. Instead of having to put infinitely many colors in your TV set to simulate the real world, TV manufacturers only have to put three, red, green, and blue, which is lucky for them, really.
All right. So it's the rods and cones. The rods are for when it's dark. You only see black and white. And then the cones see the color inside of your eyes. It's interesting when I make maps for anti-poaching patrols for tiger protection and tiger conservation in Asia, we have to think about how the rangers might be using the paper maps at night. And the colors that we put on there might look great in the daytime, but at night they're probably using a headlamp to look for their location. But they don't want to give away their location to the poachers, so they might go into red mode. So what does your map look like under red light? It's very different. So you have to make sure that certain things are going to show up on the map no matter what light they use. And it turns out that the trail that they're on, right, is super important. But other things disappear under red light, right? So it's strange, but you have to look into these things. And you would have never thought about it until we got feedback from the rangers who said, we can't see this under our red lights. So how much can you see? Well, a trained colorist, somebody who does it for a living and have worked their whole lives and maybe even just has a good genetic ability, can see 1 million different colors. That's incredible. But the average person can discern about 20,000 different colors, okay? Now, when you put it on a map, you probably don't want to go for more than 20 to 30 colors because that exceeds our ability to discern differences and absorb the data, right? Especially if we're encoding value with the color. To represent ranges of data, so if we're making a choropleth map, for example, let's stick to 5 or 6 colors, just like the 5 or 6 classes. Because after that, it gets very hard to go from the legend to the map to the legend and differentiate between them and actually pull the data that we want people to understand. So, color modes. There's 2 color modes that we'll be working in this semester. 2 color modes you might be working in for the rest of your life. And they speak specifically to how the color is generated, right? So, light color primaries are red, green, and blue. This is when we're mixing color from light in projection surfaces, on the surface of our tablet or our cell phone, computer displays, right? Or the projection computer for class. This is going to be in the red, green, blue model, RGB. Now, if we're trying to mix colors for print, we're going to use cyan, magenta, yellow, and then we throw pure black in there. So we have a nice, crisp, super dark black. This is what we call the CMYK, right? And so we call it cyan, magenta, yellow, and we throw the K in there because we wouldn't want to use a B because it would confuse people and they might think it's blue. So CMYK is what you should design in if you know that your maps are going to be printed, especially if they're going to be used for off-color or offset printing, If you're going to be using a 4-color press where they actually have a plate for each one of the different color runs, it has to be in CMYK. It gets confusing because a lot of times we're making maps that are going to be displayed online, but might be printed, but maybe that's just an inkjet printer that's using cartridges that are only RGB, right? Pretty much, if you know you're going to be designing for high-end printing, you go for CMYK. For everything else, I use RGB. You can convert between the two, but you end up with a little loss. Let's look into it a little bit deeper. So RGB, this is additive light. So this is when I'm trying to create all the colors by throwing light out of a projector. I only have 3 possibilities coming out of the projector, red, green, or blue, but how much of each one of those will let us create all of the colors in the spectrum? In the middle, if it's 100% red, green, and blue, you end up with white light, okay? It's transferred through transparent media of some kind, right? Basically projection. All the colors are added together, they equal white. The absence of light is true black. So when the projector is off, the screen is black. Because computer graphics, websites, and other digital presentations are projected, transmitted light, right? Screen graphics are targeted to be in the RGB mode, and that's what you should design them in. But it's important to note that the RGB's primaries are mixed evenly, that they create the secondary colors. So in the overlap of red and green, you see the yellow, right? And then in the overlap of red and blue, you see the magenta, right? So now you're starting to see it. And then cyan, magenta, yellow, and then the black in the back. When we go into mixing watercolors, we'll be using that style of cyan, magenta, and yellow to create the colors. All right, CMYK, subtractive pigment. This is when we're making it and our background is white, right? So these primaries were derived from RGB because that's what our eyes see and that is what is in light, or it's part of what comes out of natural light from the sun. But the main reason that they're promoted for their own color model is because it's much easier for us to mix all the other colors based on adding pigments in a printable surface, right? Or onto a printable surface. Color is absorbed and reflected by the media. So basically when you put down yellow paint, that yellow paint will absorb all the other spectrum and just reflect the yellow spectrum of light. All right. And because these colors are achieved via reflection, we assume that a pure white background is the base for all of it. And it makes sense because most of our media is printed on white paper. Now, if you print your maps on an off-white, it does change the colors. I've noticed with my conservation maps that we go from designing on pure white and even printing proofs on pure white, but then we went for a waterproof map paper that they could use in the field. And it was slightly yellowish in color. It changed everything, and we had to go back and adjust our colors for that final output. All the colors added together equals near black, but it's not a pure black. It doesn't look quite as black as the absence of color. So they added in the K so you could get 100% black. All right? Super. So the color wheel. The color wheel is a great thing because it helps you understand color theory. You can have your primaries, your secondaries, your tertiary colors, and they're all derived from mixes of the base, right? So it starts out with RGB, and then where they overlap becomes your CMYK, right? And then as you mix little bits of each one of those, you start to fill in the color wheel. So let's take a quick look at this.
Hi everyone. The variety of paint colors out there is truly staggering, but today I'll show you that you can make a lot of them by mixing just 3, red, yellow, and blue. The colors listed here are my choices, but you can experiment with other reds, yellows, and blues as well. I'm making 2 color wheels today. For these, I traced around a CD with a pencil. Using a ruler, I divided one into 6 sections and the other into 12. They don't have to be perfect, just eyeball it. As you can see, I'm filling in the wedges with yellow, red, and blue. These are the primary colors, and I'll create the rest of my colors by mixing these 3. You can't mix colors to make red, yellow, or blue, though. As a little kid, this idea always seemed so obvious to me. Red, yellow, and blue were the kings of my crayon box. I also remember a little song on Captain Kangaroo about mixing red, yellow, and blue to make a rainbow, so really, color mixing has been with me since before I could read. And look at that blue. Ultramarine blue used to be so expensive and difficult to obtain that European artists around 600 years ago reserved it for special things like the Virgin Mary's cloak. I fall in love with it every time I use it. Secondary colors are produced when you mix 2 primaries. I feel like a chemist or magician when I mix colors. You've got 2 completely different colors, and the second you put them together, you get this whole new thing. It is so much fun. Red and yellow make orange, and in this case, it's a slightly subdued orange because alizarin crimson is a cool or bluish red. Yellow and blue make green. These 2 create a sort of deep olive green. And blue and red make purple or violet. Alizarin crimson and ultramarine blue make a gorgeous one. The primaries and secondaries create a standard 6-color wheel, but the other wheel still has some spaces. I'm painting fast here and leaving some little white gaps so the colors don't flow together, but if you want a perfect wheel, you should wait for the neighboring colors to dry before moving on. I'll fill these gaps with tertiary or third colors, and you get those by mixing primaries with secondaries. This produces hyphenated colors like yellow-orange, red-orange, violet-red, blue-violet or indigo, yellow-green, and blue-green, or green-blue. You can play around with all of these names. So there you go. All the colors of the rainbow from just 3.
All right. So, love playing with the color wheel. We're going to be doing this exercise. So this week in our live lecture outside, I ask everybody to bring their watercolors. I'll bring the water in some little trays, and we're going to actually paint some color wheels. I think it really helps you understand how you're choosing colors. Okay, if you understand how the colors are mixed along the edges of the wheel, then you'll probably be able to understand the differences in how the palettes are made inside of Illustrator and Photoshop. Okay, so analogous colors imply order. They're harmonious, and these are colors that are side by side on the color wheel. And you can go down in the color picker and grab those colors, right? And then you can set the base color, whether it's purple, blue, and it'll create an entire palette based on the first one that you click. It's very, very handy to be able to go in and do that, right? Split complementary. That means it's going to start at one primary color, come down and go to that Y with one color in between them. And you can actually choose those out, and that's what they would look like. It's a double click on everything today. Triadic, right? So this is a perfect like P symbol in the color wheel, right? Now, all of these colors are the full saturated colors. We can lighten them up by adding tint. We can actually desaturate them and subdue them a little bit, but this is where we start, right? Double complementary, so the X is across the color wheel, right? With only one space in between the 2 primaries at one end. And the tetrad, right? And this is like the perfect X 4-way, right? this is the base. This is where we start. And then we start working it down into a tetrad that would feel nice on the map. So you're going to have to reduce the saturation, maybe add some white, some tint to it, right? Usually we don't add the blacks to it. It's already too dark. So how do we have subjective reactions to color and then throw that onto our maps? Well, when we're designing, we're trying to take care of everybody, right? So the hardest map to design for, hardest audience actually to design for, is the general audience. We're trying to make a map that will feel good for everyone. Well, what we can do is say that there are already groups of colors that have certain emotional appeal to the majority of people. So that might be the best that we can do. So cool colors, in the blues, the greens, what make you feel like a cool breeze or a nice sky, or you're next to a body of water. So there is already a swatch palette for cool colors. So we can go and grab a few of those. Each swatch folder has different mixes based on the color wheel, and we can bring those right into our swatch palette and then apply them to our maps. Warm colors, right? So the colors that make you think of a nice light running in the evening into the house, fall colors, right? All of these types of things, yellows, oranges, lighter reds. Again, they have warm color palettes ready to go. Saturated colors. These are these full kid colors. You could almost call this palette kid stuff again. Won't use it too often on a map, but if I have one thing that everybody has to recognize on the map, I might choose one of these saturated colors and make that particular item a saturated, very deep, rich color, so that when you look across the desaturated page, that one thing pops. Bright colors, again, for saturation. If you're making a map, to a kid's birthday party, you might get away with using these palettes. But don't discount them completely, because you can start with these colors and then mess with transparency or adding tint to them to really desaturate and take them down. Okay? Tranquil colors. Now, this is an okay place to start. The soft colors, though, that palette reminds me, more of the muted, like Easter egg colors that you would see, really. Desaturated might be a better place to start. And then natural colors. I believe that the natural colors on maps is the way to go. We're trying to emulate the real world, and unless the map is really abstract and it's all about just data, and we want to have it have any association with what people might find out there in the landscape, then natural landscape colors and stone, brick, they even have shoreline colors. Those all feel really nice when they're put together in maps. And each one of these little folders are those colors on a color wheel, so they should work together really nicely. So Tufte is kind of the leader in this. He really says, anytime you're making a map, you should try to complement it with natural colors. All right, cartography isn't about using candy cane colors. It still gets done, but I think a good way to start is with something like this. So this is an image from one of his publications that shows one forest throughout all the seasons of the year. You can take these individual pictures or this collage of all of them and feed them into a palette generator, and I'll give you some links at the end of this presentation, that will create a palette of all of these colors that then can be fed right into your design software. So natural colors just feel better when we look at them. We're so used to seeing them. We've evolved working in these colors out in the landscape, right? Our eyes are highly tuned to these colors. So it just makes sense that they feel better when we put them on maps versus the man-made environment, which has only been around a couple of 100 years, and all the crazy colors that we have devised, right? Mostly by advertisers trying to get your attention. Look at that. Take a nice picture of a piece of bark and generate a palette from it. All those beautiful browns that you will see in there. Really slick. Or a field of flowers. Get some really nice colors out of that. And they might be oversaturated, but you can always tone them back. The thing is when you're putting things in layers inside of Illustrator for your maps, you're almost always doing some form of transparency so that things don't feel like they're floating over the landscape, so they kind of blend into it, and that really reduces the colors. You have to be careful, though, if it's a really colorful background and you have a line that's one color, it'll actually change color all along the line, depending on the amount of transparency that you have. All right, so color and cartographic design. I can give you a few guidelines. Is there absolutes? Not really. We start with these guidelines, and then from there, we build our experience. We let people look at our work. We take that feedback and internalize it, change up our ideas of what the audience is going to like, regardless of what we think is hot, right? And then we grow as an artist and we make better compositions. But it's a nice place to have a starting line when you get to the races. So what do we use color for? To label, right? It indicates differences, not only because we might use different types, but we might start to get a really complex map and we run out of options for different typesets. So we can change things. We can also change its hierarchy on the map using color. And we also use it to associate things like standard stuff, blue equals water generally. To measure and distinguish. So to indicate different amounts of some data. And this is really common, obviously, in thematic mapping, right? We will use color to show differences in degree and differences in the analysis that we've done with the data in the background. And to represent and imitate reality, right? So to color water blue and land green and snow white, it doesn't seem too out of the ordinary. You would expect to see that. In fact, we expect it so much that when you do not follow these guidelines, it instantly bothers people as they look at your map. Imagine if you were to see a map where all the rivers were red. You'd think there's a problem, right? What would you think? Maybe there's danger in those rivers, right? Or there's an algae bloom or something, right? And then to add beauty, just to make our maps pleasing. A map that wants to be looked at is so much closer to its original purpose, which is to communicate, than an ugly map. There's no point in even putting ugly maps out there because we just walk away. All right, so here it is to label. We have a map. It's just showing Twitter's territory across the United States. So you've got a nice choropleth map in the background, but the black borders of all the states would make it really hard to label things in black if you crossed over anything. So they went with white labeling. It just makes it stand out better and gives you more options. That's pretty much the rule. If you have any black lines at all on your map, then you can't use black type, all right? Because it's just too likely that you're going to have crashing type on black lines. So remember that. If you choose black line work, then you're going to have to go to other colors for your type. To measure. So here we have red. We don't even know. There's no legend. We don't know what this represents, the surface that's been colored in this hypsometric tint. But obviously, the red is the most dangerous part of it, right? It looks to me like it could be a volcanic caldera around Yellowstone, right? Something along those lines. But we know that is the hot spot. To add realism, we'll be looking at a lot of Baran's work. But to take colors from nature and make your map actually look like it belongs in that landscape, right? And then to add beauty, right? Look at this map. Look at the use of color. It's in Japanese. I can't read a word on it, but I want to understand the data. I want to understand what it's showing just because it's so nice to look at. Look at the way that they did their bar graph with this like return. What exactly does that mean? I need somebody to translate it for me, but I've spent a lot of time just looking at it and wondering, how did they compose this? Where did they get their palette from? What does it all mean, right? Probably more time than I should have, since I can't get any information off of it because I don't read Japanese. Or all four purposes in one map. What happens when you add all the right things in there? Right color schemes, right type, right data? You end up with a work of art, a thing of beauty, communication that is functional. And that is the ultimate goal in cartography. So, some guidelines. You want to ensure legibility with high contrast, right? So use color to help you differentiate your type. You want to provide sufficient contrast between colors so that the eye can see the difference, right? You can't have blues that are too close to each other because then you won't be able to see the difference. And this is especially important if you're actually showing measurement with color, right? So amount. Tufte suggests the careful use of bright colors over grayish backgrounds. That tends to work, right? Especially in thematic cartography, you make your base map very subdued and bring the data up into the hierarchy. Heightened perception and communication of the message through the use of conventional hues. So this means use color that we expect, blue for water, right? It's just one of those things. I think you guys understand this. Green for vegetation. And then use conventional values and chroma levels for amount, right? So dark colors tend to equal more. They're heavier. They have more weight. So they have more value versus bright colors mean less, right? And then also the colors that we expect as far as what they communicate through their personality, right? We looked at this, and in the west, certainly green means safety, go. Moving on to yellow, caution. Moving on to red, danger. So if you were trying to map radioactivity across a landscape, right, that would be a perfectly useful color scheme to use because people would understand it innately, be part of them. And then strive for balance and harmony. Take the time to step back from your map and squint at it and look and go, And then how does it look when I'm really close to it? Go beyond map presentation, right? We want to certainly present a nice product, but really create map art. Think about creating something that you would be proud to have framed and have on the wall in somebody else's house, let alone yours. Okay? All right. So here's some practical color for cartography. These are all links that'll be in the PowerPoint, that'll be in the description down here. Color Brewer, a great website to see what different colors will look like on maps. And once you find one that you like, you can export out the actual palette, bring it right into the software. Then palette generators. Palette generators are very handy. You can either upload an image that you've taken or the URL of an image you found online, and it will generate a palette for you that you can either download or you can just write down the hexadecimal numbers and plug them right into the color picker inside of either Illustrator or Photoshop, and InDesign for that matter. Or Palatine. Palatine is a really dense website for designers, and it lets you go through print versus web design versus design for apps, design for gaming, and all these different ways that color influences how you should design those particular applications, right? A great article with 20 color tools, color test. I'd like everybody to go to that link and take that color test. So that's the Pantone Corporation who makes huge color books and then inks that represent those colors that can go to the offset printing process. But the color test has 3 rows of hued colors that are just slightly off, and it asks you to put them in order so you can grab the little swatches and move them around and go from light to dark and see what you can do as far as a score goes, all right? It's important to understand how good your color sense is, but know that it is something that you can, over time, learn and get better at, right? And then Adobe Color. So Adobe used to have Cooler. Now they just call it Adobe Color. This is also a palette generator, but the nice thing is you can save it right to your cloud environment. And then if you have a connection through your software, you can bring it right in through your library, right into the software. And then maybe one of the coolest things that I found in the last couple of years, Adobe Capture. It's an app for your Android or your Apple phone, and it allows you to, when you're out in the wild, you see a map that you love, you can take a picture of it and tell it, generate palette, and it will create a color palette off of all the colors that are in that map. And then, of course, save it right to your cloud account and bring it right into the software. It also lets you identify fonts. So you can take a picture of a font, and if it's an old font that you haven't ever seen before, it'll try and find one that's closest to it and let you know if you have access to it in Typekit. It's a really cool tool that does a lot of fun stuff. It makes going for walks and visiting libraries in the old map department a pretty fun little excursion. Cool. Well, that's all I have for you today. I hope you enjoyed this. If you did, please like the video and subscribe to the channel, and I'll see you next time. Take care.